Hello, everyone. This is Christian here from Pebble, and I'm here to talk to you about NMOS device control and monitoring. I'm one of the main contributors in the activity group, and just wanted today to talk to you a bit about some of the resources available to implementers. This is a very important area for the NMOS community, and it's got a lot of work done in the last, 6 months, and we want to let you know about the resources we have in place. So today we're going to look at some actual code and the implementer's guide. But before we go into that, I just wanted to kind of give you a brief little overview as to, what the space is, the ecosystem we're talking about. So most of you will know about NMOS ISO 4 discovery and registration and connection management, ISO 5. So we got ISO 4 in this column, resource management, and ISO 5 in this column, connection management. But today we're going to focus on this column, which is device control and monitoring. And I'm going to show you briefly a lovely diagram that I enjoy. Is kind of a squid diagram around how we've established this ecosystem and NMOS device control and monitoring. So it kind of relies on different parts, different logical parts playing really nice together and splitting the problem space into different parts that we can then solve with the best tools that are available. So we've got MSO 502 on the left-hand side, which is the modeling language. So this is how we define what, data types and what object entities, what classes you can create. And there are core classes that, are really needed for everything. But then vendors can also define their own classes. So they can create their own vendor-specific objects with their own vendor-specific data types, which all need to be discoverable by the same means. So, anyone can use those as well, but they are not part of the standard set effectively. So you got MSO 502 establishing those rules. Then you need a way to interact with those models with that device structure. So you have IS-12, which is our communication protocol, and that relies on trusted web technologies. It relies on WebSocket transport, and we send JSON payloads over that. And it's bidirectional, so it allows for both control and notifications to kind of flow backwards and forwards. And that is how you interact with those models. It's really efficient, really compact, and also straightforward to debug and to look at it. And also you can, create a web app entirely in the browser that can control one of those endpoints. You can use a WebSocket extension for a browser to poke around devices. So we thought about some of these non-functional requirements, let's say. The other element of this is the BCP-008 subsuite, if you will, and that kind of establishes monitoring behaviors of some of these media devices. Very, very specific, feature specific. So for example, we've got BCP-081, which is receiver monitoring. So how do you describe receiver statuses via this kind of framework? And then we have BCP-0802, which is the counterpart for senders. And those all establish kind of requirements and behavior on top of having the transport conformance, message payload conformance, and data types and classes in that language. And all of these play really nicely together in one kind of big set of conformant devices, which are still very distinctive. They have their own secret sauces, that features they can do, but they are all advertised and interactable using the same protocol, the same discovery means, by a controller, right? So that's where we are, and I'll show you briefly kind of where everything is again. So if you go to specs.amwa.tv, that forwards you to this nice portal. You can also go directly to specs.amwa.tv/spec/NMOS, or you can just click here on the NMOS tab, and that directs you to the NMOS portal. So you got specs.amwa.tv/NMOS, and here, if I close this tab, here, basically, you've got a rendition of diagram I just showed you with the columns, this one, right? You've got a rendition of that in table format with all the links and the versions and everything. So you've got resource management, connection management, device control and monitoring. And the one that we're going to focus today is actually in here, device control and monitoring, right? And specifically, we're going to focus on the implementer's guide. So info 6, which effectively is you can view it as the point of entry into this. So you've got references and guidance for all of the other subparts in there. And it's just a nice way of looking into it. So we're going to look at that. That's one of the main resources for today's video. But also what we're going to use today is we're going to use a controller to kind of show you some of the operational feel of the ecosystem, but also we're going to use what we call the NMOS device control model. And this is another open source application. It's a TypeScript Node.js application that you can use. Is rendered here, the documentation, but it's on GitHub. So, if you navigate to this link, there are links to this throughout the specs as well. And effectively, you can, once you have Node.js installed, you can install all its dependencies using npm install, and then you can build it, or you can build and start it. Or if you want to make changes to the code base, you can run npm run serve, which effectively recompiles the application if you make any changes. And we're going to see that today. So that's the specs.iml.tv link. But obviously, if you search for this, you will find the GitHub repo as well. So all of that documentation is here as well. And the way you grab this, you obviously you can do a git clone of this. It's all in the public domain, or you can just grab a zip file if you want, or whichever way you want to do it. So once you kind of pull that in, you're going to have something that looks a bit like this. I'm going to drag this across the screen so you can see. So if I go to the main folder, so you've got something like this. So it's got some of the documentation, but what we're interested in is the code there, right? So if you go to the code, and for this kind of section, I'm just going to open it in Visual Studio Code. So I've opened it here. And gonna make this bigger and smaller. Let's try that again. Just gonna open it again. Some Windows technical difficulties. Switching from one screen to another. Okay, so we've opened that in Visual Studio Code, and I'm in the code subfolder. I'm just going to wait for the terminal to load here, just to show you how you can run this in those two ways. So if I do first one, npm run build and start, so this will compile the application and run it up. So it'll take a couple of seconds, but it will show you what's doing in there. So we'll wait for that to finish, and that should run up. And I should have said for this, I've also got an NMOS CPP registry running in the background. You can configure this if you look at the documentation. You can run this without a registry. You just have to change one of the configuration items in there. For this demo, I've got the registry running here, the NMOS CPP registry. So all is good. And now I'm just going to copy those compiled files to the distribution folder and then hopefully run it up. And then we can look at our controller just to kind of establish the environment we're in and give you a brief look at what we have for the mock device. And then we're going to go back to the implementer's guide. There we go. So that's all up and running. It's on port 49999, and it's registered in the registry, and it's already starting to communicate with the controller. So let's have a look at that. So we got our controller up and running here, and that shows up as this NCO1 node. So this is our ISO4 node. It's got a device, and it's got a receiver and a sender. And you'll see that device has a control endpoint. We're going to look at this through the lens of the implementer's checklist in a second, but this is just to show you. So this is the IS-12 control endpoint in here. So this is how the controller interacts with our device. And if I briefly do a little exploration of that, you'll see this is our device structure. So it's got a root, it's got a device manager, a class manager. We're going to look at that in a minute. Receiver, senders, stereo gain, and some example controls. And all of these seem to have properties and methods, and we're going to look at that in a minute. So that's good. If we return back to some of our documentation here, you're going to see me glance to the right-hand side of the screen every now and again, just because I've got some notes there that I'm trying to remember to explain. So yeah, apologize if you see me glancing to the right-hand side. I'm just trying not to miss anything important. So let's start to look at the info 6. So you see I've got most of these specifications already open. So we've got, if I moved it, recording top straps here. We've got, as I said, the device control and monitoring table here. I've opened IS-12 here separately, MS-0502 separately, BCP-008 and 02, and then info 6, which is the one we're going to focus today. And obviously, you've got the device control mock here. I can close these down because I've already opened and pulled the application while running it. Actually, in the meantime, before we do that, what I'm going to do is I'm going to close this, and we're going to say npm run serve here, which basically allows us to make changes to the code base and them to recompile. So I'm going to do that. It's going to, again, run to the recompilation stage. We're going to let that run in the background there. So info 6, the implementation guide, right? So this effectively tries to guide the reader through some of these workflows for both media nodes, which we're going to focus on today, and controllers, right? And it's going to explain some of these concepts around modeling, around the control protocol, around the behaviors of BCP-008, 1 and 02. And we think it's a really, really good guide. So if you go to the tutorials page, then it kind of starts with a preamble. It talks about which references it's using and which resources it's counting on. Later on, you'll see it uses the mock device and uses the WebSocket extension. Links to the API testing tool, which we might do a separate video on, and also links to some of our open source libraries like NMOS CPP, which has support for IS-12 already, and support for BCP-008 or 102 is imminently coming. But yeah, we can navigate through this. We're going to go to the next page, which is the device implementation tutorial. So this is the one that we're going to focus on today. And the beauty with this is it starts off with a very quick checklist of things that are very important to get working in a new implementation. So, treat this almost as a cheat sheet or, a very, very good checklist. Things that you need to kind of get right to get to maybe 90% of compliance. And then there might be some other detail that you need to kind of mop up at the end. But generally, these are some of the most important aspects you need to get up and running. So we're going to go and look through this specifically today. And we're going to look at the NMOS control mock device and how some of these items in the checklist have been done in there, right? So that's what I want to do today. But briefly, we're going to go through the document. So for all of these items in the checklist, you will have some guidance sections below explaining them and explaining what they mean with diagrams. I'm not going to go into that today because you can go through that offline. This is why I wanted to actually show you a real implementation like the mock device, how that's been achieved in the code. So yeah, I'm just going to scroll through this. There's a lot of very useful information in here, so definitely try and get familiar with all of this content. And then if you go to the next page, we're not going to focus on today, but there's basically the flip side of the problem, right? You have the control implementation and you have a similar checklist, but now from the point of view of a controller, right? So how would a controller get up and running? What would it need to kind of do? What are the expectations for it? So again, you've got nice guidance in here with that checklist diagram. So very, very good content to get familiar with. We're not going to look at this today. And finally, what I want to mention is there's a final section called a how-to practical example. And what this does, it actually talks through a full end-to-end series of get it up and running with an NMOS registry, getting up and running with the mock device, and then using a web browser and a WebSocket extension to pretend you're a controller from first principles, just sending IS-12 commands, looking at the responses, and doing certain actions, right? So you'll see things like, locating the IS-12 WebSocket control endpoint, Then you have things like finding the members of the root block, right? So finding what members are at the top level of your device, and then targeting a specific object in there, changing some of its properties, and looking at the request and response, the command and the response that you get back from a device, right? Subscribing to property change events and receiving notifications, seeing how that works, right? And you'll see some of these live working in your WebSocket extension. So all of this is a very, very good exercise. So I recommend you do it. It should be straightforward to follow. All of these have been tried with the mock device. So it's a good learning exercise. But let's go back to where we said we're going to focus on today, which is the device implementation section, and specifically this checklist. So we're going to go through this. So I'm going to go point at references in each individual relevant spec and then look at the code base, right? So we start from the top. So you need to implement some control classes, right, for your device. So first of all, you have NC objects, which is the base class model for every single other object in NMOS control and monitoring. So any single object that you create, even if it's vendor specific, has to either directly or indirectly derive from this baseline object. And you'll see why that in a minute. So there are some sub checkpoints in here, sub check items in here, which we're going to look at. And this is defined in MSO 502 in the framework, right? We said the framework governs the modeling language. So that's where all these core classes are defined. So we're going to look at NC objects. So we need to find that it has a no ID. We need to find that it has a role, which then obviously then all objects derived from it have a role within their block owner. We're going to look at blocks afterwards. They all have a class ID. So basically defining which entity they represent, which class they represent, and they have this get and set method. So this is how you can get any property value from the property list or set a property value, right? And then you also have the property changed event. So we're going to look at that. Let's have a look at MSO 502. So if we look in here, the best place to go here to find models is to go to the framework. So this kind of lists all the control classes and data types. We're going to look at NC object, which is right here. And then you see a WebIDL rendition of this, which is very nice because this kind of maps really well to almost code base, right? So we're going to see it's got control class 1 here. This is the class ID that we're going to use. So it's the first one because it's the one that every single thing will derive directly or indirectly from. They also have to list their class ID so we can easily inquire them in the code base when we interact with an object from IS-12. So you have a class ID property, you have an OID property, so an object identifier, which is a numeric one. And you have a role. So this is the role, which is a string kind of value, the role of that object within its block, within its structure, owning structure. And let's see what else we had in there. So if we go back to the implementation, so we looked at role, class ID, and yeah, get and set methods and the property change events. So if we look at those, so we've got our generic get method. So this is how you get any property value of the properties of that device, of that object. And then we have a set value, which is obviously the counter price. So you need to specify the property ID with level and index. So this bit here. So that's the level and that's the index. And that's how you get the value back, right? Or you can set back. So you need, again, to specify the property ID, but then you can also specify a value, which is obviously nullable because some properties might be nullable, some might not. These are generic. So all of the objects that you're going to implement will have to have these methods implemented. So that's kind of what the model looks like. And if we look at yeah, and we need to look at the property change event. So the property change event effectively sends a structure which has information about which property has changed, its value, and a bit more about indexes if it's a sequence type property and things like that. So we're going to look at that in a second. But that's the model for object. And that's from the checklist. So let's have a look at our application here, which has started. So NC object is in the core kind of file So we're going to look at that, and probably at the top here, we're going to see NC objects. So if you have a look, it's very, very closely related to that rendered model definition we have in the documentation. So you've got a class ID here, you've got an OID, you've got the role, which is obviously a string, and then we have a constructor. So we're passing the OID from above when we instantiate it. We're passing the role from above. And this is an abstract class. So we're never planning to use this directly. We're always gonna, use this when we instantiate other types of objects, which you'll see in a second. But we have the get method here. So this is how you get property values. So all of these values when we receive the property ID in here. And then you have a set method, which obviously you can set property values. Now there is a property called a user label. So in this case, that's read write. And this is how you'll see this being assigned. And then this will actually fire a notification. So this goes to the subscription mechanism. And if that's subscribed, then you'll see that property changing. So that's there's some more methods in here, but that's the gist of it. And also you can have methods for objects. So you can invoke other methods beyond get and set. And in this case, those are the methods, which I'm not going to focus on today. And yeah, let's move on from there to the other points in the checklist. So we're done with object. That's our NC object. Then let's look at the blocks. So the blocks are effectively, you can view them as almost like a folder structure, right? So you have a folder that has can have other folders or other files, right? So files are effectively like instances of object instances of other classes, or you can have other blocks, which are instances of NC block, which then can have their own inside blocks or other objects, right? But fundamentally, blocks all have members, and they all have some search methods to help you find members either by role paths or by the path that they occupy in that device, or by things like class ID. So for example, maybe you only want to find, I don't know, all the sender monitors or the receiver monitors. That kind of helps you. And then there's some special rules for the root block. So the root block is effectively the top container of everything in the device, right? Control structure. So we have a root block, which has a fixed static role of root and a very fixed OID. So that's how you find, that OID is always going to be 1. It always starts from the root block where it's the value of 1. So let's have a look at that in the framework. So we will have a look here. So you've got the members property. So that's level 2, index 2. That's called members, and that offers you descriptors of what members are inside that, right? We can briefly look at that if you want. Yeah, and then NC block member descriptor has the role of that member inside the block. It has its own ID. It tells you what its class ID is, so you know what type of object it is, and it also tells you about its user label. So that is the members structure. So this is how you can find, and you can iterate through this, right? You can find a particular, you can have the descriptors of particular members, and you can recurse this. So if you, for example, from the root block, say I want to find all the member descriptors, if you pass in recurse through, you will get everything inside the device effectively. So all the descriptors. But you can also find members by a role path. So you can pass back a role path, which is effectively a collection of roles, right? Starting from the root block. So that will return you back again descriptors, or you can find by role, or you can find by class ID, right? So let's have a look at that in the mock device code base. So we're going to go to blocks, and then in here, we will find our NC block, which extends from NC object, right? Because we said NC object is the base class of everything. And it's got a static class ID of 1, 1. So that should match with our rendition here. And it's got it will have an object ID, but that's already captured in NC object. And we have members, right? So member objects and members. So we got this in here. The way this works is when we instantiate an NC block, we actually pass in the member objects, and then we generate descriptors for that in here. Again, it implements the get and set generic methods. So you can, get the members And there's nothing really to set here because it doesn't have anything writable. But this is how you generate the descriptors, right? So all blocks can generate their own descriptors. And we're going to look at class descriptor in a second when we talk about a class manager. But that's our kind of block implementation. And you'll see here, if we search for it, we have a root block specific implementation. And it's not in the core, it's in here. Roots block. There we go. So root block extends NC block, right? So you see it's got fixed OID of 1 and it's got a static role of the root, right? So that's our root block. One other thing I wanted to show you is the fact that NC block has those such methods. If you look at the block methods, so we're going to scroll through those because those are part of NC object. This is our one of our search methods, right? So 2M1 being this one. So get member descriptors. So that's how you can get the member descriptors. And then that's find members by path and by class ID. So finding members by role path, right? So this is how you can find members by role path. And this one was finding members by class ID. So this is how those are implemented there, and then retrieving those member descriptors from the block. And if I briefly go back here, blocks are effectively, the root is a block which has sometimes instances of objects, sometimes it has other blocks, like this example controls block. That is another block. And that has currently one instance of example control 1, which is an object, right? And all of these are properties. So you can see kind of how blocks kind of help you structure the layout of a device. So that's, let's go back to the checklist, make sure we haven't missed anything. So we can now start looking at one of the instances that we use for a block, for example. So all of these are instantiated in our server file. So if we look here at the top, we will have some of these blocks instantiated. Let's see, NC block. Yeah, there we go. We've got stereo gain block, for example, which we're allocating an OID for and passing it in. We're passing in what role is going to be and what its owner is going to be and things like that. And then we are also passing in the members of it later on. See here, we're basically saying that stereo gain block has a channel gain block and a master gain and so on. So if we scroll down, we will see the root block appearing somewhere. So that's the root block, which is defined here. So at the top, we've got the root block, and then we're passing in the child members in here. So effectively all of those things that you saw in the controller. So we've got device manager, class manager, and other blocks in there and other objects in there. So that's how we update the members, how we instantiate these objects. So that's our blocks kind of checklist. Then we need to talk a bit about managers. So managers kind of are very specific classes and they're singletons. So you can only have one of them in the root block. And they handle things about, for example, device manager implements basic device information like, firmware versions and product versions and product names and that kind of stuff. And then the class manager implements the discovery means, so how you discover classes and data types of anything that you use in that device. So we're going to look at that briefly here in the framework. So we go to NC device manager. And that again has a class ID of 1.3.1 and a fixed role device manager. And it's got a bunch of properties. It's got a version of MSO 502 that it's using to model this device structure, information about manufacturer, products, serial number, and so on. So we're just going to briefly look at that here in the manager's file and see device manager. It extends a manager abstract class here. And that's just so you can easily find things by managers. If you want to find all the managers, you can just search by the NC managers class ID. So yeah, it's got the, version, it's got manufacturer, product, serial number, and it follows the same patterns. And you'll see NC manager then derives from NC object. So then therefore a device manager also derives from NC object. That's the constructor. We're populating all those values. And then again, we have a get method to get values of all the properties. We have a set method for things that can be writable, and those end up in notifications if they've been subscribed to, and so on. And then for the class manager, which is definitely a bit more interesting and crucial for the whole ecosystem. Class manager, as I said, has control classes and data types. And these are descriptors of all the classes used by objects in the device and all the data types, including vendor-specific ones. So that means the controller can use vendor-specific functionality using effectively generic first principles by just discovering every single bit of property in a generic way. So that really, really helps with interoperability. And there's some methods as well where you can request a particular class ID descriptor or particular data type descriptor using their ID or their name, right? So let's have a look at that. And that has an ID of 132 in it. So, 132 and a class manager has a static role. So that's the class manager in there. And we generate all of these class descriptors, right? So you'll see all of the objects, all of the classes that we have actually have a static get class descriptor method, which just generate that descriptor for you. So every time we get call with their identifier, we can respond with the right class descriptor. And it's similar for data types, but in the case of data types, we actually we store all of those in here in the class manager. So all of these are specific data types. They might be primitives or they might be enums, right? Like in this case, or they might be structures, right? So if we find a particular interesting one, let's see, data type. It's a lot of enums. Mission status. Yeah, for example, this one. So data types will have their own get type descriptor method that you can call a static version of that. So all of these effectively feed into those two properties, and that's how a controller can generically find any class being used by any object in a device and any type used by a property in a device, right? So it is very, very, very strong. Discovery is kind of built in, full discovery, right? So that's good. Let's see. We've looked at the managers. So now we need to start looking at the protocol, right? So for now, we're going to go into the IS-12 documentation. So obviously specs.imo.tv IS-12, or you can navigate, say, from the table here. Again, I'm not going to go into the entire documentation here. We're going to focus on the protocol messaging because that's kind of the crucial bit. So you basically have a bunch of commands and responses that you can send to a control endpoint. There is an IS-12 control endpoint that wraps around those device models that we looked at earlier, right? So you can talk to the root, or you can talk to a sub-object, or you can talk to another nested object, and so on. So you have a command that you can send, and you get a response back. You can subscribe to things and you get a response of what you've been subscribed to and if it's been successful. And then for all of those subscriptions, you can get notifications. So all of the objects you've been subscribed to, if their properties change, you get notifications for them, right? That's kind of the summary of it. If you look at here, first of all, we need to be able to advertise that we have an IS-12 control endpoint in our controls array in our device, right? And that's explained in IS-12 in a particular section here. So this is common practice. ISO 5 needs to be in there. If you have an ISO 5 endpoint, if you have an ISO 8 endpoint, if you have any sort of control endpoint, it needs to be in here. So this is the way you do it for IS-12. So you have a control endpoint that starts with URNX NMOS Control NCP. You have the version number, and then you have a URL where it's basically the WebSocket URL where a client can connect. So let's see how that's done in the mock device. So we're going to look at our NMOS device resource definition here. And you'll see that's got UID, it's got labels and stuff. And it derives from a kind of base NMOS resource. So this is our ISO4 device resource, right? And in here, you'll see we've got a controls array, and then here we're passing in ISO5, right? So connection management, both versions, 1.0, 1.1. And we're also passing in our NMOS control NCP IS-12 endpoint. And this is the WebSocket that devices are going to connect, clients are going to connect to, right? And you'll see then, if we go to look at the server file, this is basically the only URL we will allow upgrades from an HTTP request to your WebSocket request, right? So you need to actually use that to kind of establish the WebSocket, right? So it's important, and this is how discovery of the endpoint works. So that's that point. And then you have various commands, right? And responses that you can send. So mapping commands and responses to objects, right? So if we look at IS-12, where is it? In here, I'm going to go back to commands, messaging, right? And the command type, right? So the commands have a handle. So basically an ID of that command. So a device can then respond to that particular command, right? So they can be paired, and that's really useful for the client, for the controller. It doesn't really help the device, but it's just so the controller can pair a command with a response. Then we have the OID, so the unique identifier of the object you want to talk to, right? Through that command. You pass in the method identifier, so which method you would like to call from that object, right? If you want to call the get and set generic methods, you use their identifier, right? And then you just pass in their arguments effectively as a dictionary. So all the arguments of the commands need to be passed in the dictionary. There might be methods that do not have any arguments, in which case you pass in an empty object in there. So that's those are commands, and then for each of those, you will get back, as I said, a response which has the handle, and then that has the result, and the result will always derive from this NC method result, right? So it will always have a status, and then if it's an error, it will have an error message, or if it's a method that has a response or result back, you will get the value of that result, right? So if we look at, again, at the objects, right, NC objects, you'll see, for example, the get, right? So you pass in you send the command, you need to pass in the property ID, right? But then you get back an NC method result property value. So if we look at that, then you'll see that derives from NC method results. So it will have the status, so whether it succeeded or not, but it will also have the value of that property, right? So this is how you get the value of a property when you start up as a client or a controller. So let's see how that kind of works in practice. So if we look at the server again, and then we're going to go to the WebSocket section. This is how we initialize WebSocket, and we basically pass all the messages that we receive as commands to the root block, right? So we go to the root block, and then the root block says, I've got a command, I need to process it, right? And then we go to process those commands, and then we check, is it one of those generic getters? So is it part of the baseline NC object generic getter? Then we just need to find the nested member, the object that command is trying to interact with by the OID, right? So we find that member, and then we just say, hey, by the way, I want to call your get method, right? And then return a response, right? If we can't find it, then we return an error. So we say, sorry, that OID, I don't know what that is. I can't find that member with that. Same applies for using the generic setter, right? If you're trying to set something on an object, you need to find that nested member inside one of the many blocks that you might have, and then call that set method, right? And then return back a response, or you see that returns the command response no value, whereas this one will return back a different kind of response. But again, if you have an error, you'd return a response error. And then if they're not any of those two, then basically it means that they're a completely independent method, right? Another method that that object implements. So then you just need to call that method, right? So you still need to find the nested member by object ID. And that, that has just a bunch of recursion here to find through all the nested blocks the right identifier. And then you look that method, and then it's either successful or you return back a response. So that's kind of how all those map into the models. So you talk, in this case, we talk through the root block to any of the nested objects that match our OID, and then invoke the right method, either a get, a set, or any other method, right? So that's how that works. And then obviously you have subscriptions and notifications, right? So let's look at, say, a nice example like our NC objects, because all objects have to have a user label, which is writable, right? So we'll look at the user label, that's 1p6, so level 1 index 6. And you can retrieve the user label, which by default might be null, or you can set it. And when you set it, here we're setting the user label using the generic set method. This will try to generate a notification, right? So it goes into our what we call a notification context, and that's kind of our session manager. So if you look at that, that goes into here, and our session manager implements that notification context, and that implements our notify property change, right? So this, if you look here, effectively takes in the identifier of the object, right? So, well, object calls that notification. It tells us what's the ID of the property that its value changed, and then the value, which could be any type of structure, or it could be null. And if it's a sequence type property, then we might want to know the index that has changed within that sequence, right? But this will loop through all the sessions. So you might have multiple WebSocket connections from multiple clients, all subscribing to different things. Ignore this first bit because this is for debugging purposes. So you can just fire notifications without subscribing. And that's kind of a specific thing for this implementation. But basically what we do is we check whether those sessions have a subscription that includes our object identifier, right? And if so, then we should send them a notification, right? So it's simple. It's just basically a dictionary that just checks, have I got this object identifier in my subscription list, right? And if so, then send them a notification. If not, then we won't send them a notification. We'll move on to the next session that we have open with another client. And these you should see, they should map very, very well to the IS-12 notification message. So you have the OID, as I said. You have the event ID. So that is property changed event. So if we look at here, back to the NC object, it will have this. So that's the property changed event. So you know that that's kind of the event that you're receiving. And you also need to have the event data, right? Which is NC property changed event data. You look, that's the property ID, that's the change type. So the fact that it's a property changed event, the value, which is nullable, and that sequence item index. So these all maps here to our property identifier, the value, and the sequence item index, right? And this is the event ID 11, since it's the only event that we basically have mapped so far in the specifications. So that's how notifications work. And that's this point here. So once you reach this stage, you effectively have you should have nearly a compliant baseline IS-12 MSO502 device, right? So you have these if you've implemented, all the necessary managers, and we've got a root block and NC object and everything derives from NC object, then you have a baseline implementation. Now, what you can do is if your device has specific functionality like senders and receivers, and you can connect them using connection management, then this is the next bit that we're working on, is BCP-008 and BCP-008, right? So these are the behavior sections, right? This is how you can monitor a sender that you can connect using ISO 5 and a receiver that you can connect using ISO 5, using IS-12 and expressing their models using MS-0502 modeling. So let's look at that. So we've got status monitors, right? You can implement the NC status monitor class, and then that has an overall status, and then you can implement sender and receiver monitors. So let's look a bit at BCP-008 just to see how that's kind of structured. And we'll look at a particular diagram in here. So you've got the NC status monitor, which is the kind of parent of all other status monitors. Currently, we have receiver monitors and sender monitors. They both derive from status monitor. And there's a particular reason for that. It's because the status monitor has an overall status. So that combines all the domain statuses into a single property. So it very much simplifies for a very simplistic client. They can just take in this overall status and still get a very good indication of the health of that component, right? You have an overall status message, status reporting delay, and other properties. And then you have domains, right? So you have connectivity, synchronization, string validation, and each of them has different statuses: link status, connection status, synchronization status to do with, PTP, lock, and that kind of thing. And then stream status: am I receiving the correct stream? Can I decode the stream, right? And these are very similar across the receive monitor and sender monitor. If we look at the sender monitor, you'll see that that has effectively, instead of connectivity connection, it has transmission status because it's transmitting, and it also has essence status. So what's feeding into the stream that I'm sending onto the network, right? And can I give you information about the health of that portion of the workflow? Again, derives from NC status monitor. So all of these models, that's a nice diagram visually, but all of those models are defined in what we call the feature sets register. And this effectively acts as an extension to MS-0502. So MS-0502 has the core models, and the feature set has the feature-specific models. So if you implement those features, you need to use those models. If you don't, then obviously you're not going to have those models. They are feature by feature models. So this is the monitoring feature set, and this has those models. So let's briefly look at, for example, receiver monitor, right? So this again has a class ID. It derives from NC status monitor, which is the one we said has the overall status. So that's 1.2.2, and that derives from an NC worker, which is defined in our base framework, right? So NC worker. And this is so you can easily find workers again using those search methods. So back to here, we've got a status monitor, and we've got a receiver monitor and the sender monitor, depending on if you have both receivers and senders. They all have different properties, and they have some methods. For example, getting the lost late packets and resetting counters and messages. Similar, the sender monitor has a transmission status instead of a connection status, has an essence status instead of stream status, and has transmission error counters instead, but it still can reset counters and messages. So these are very important. They map to that diagram that I showed you earlier. I'm not going to go into that documentation and that specification specifically, but what I'm going to look at is how these models have been implemented and where to find them in the mock device, right? So back to our checklist, we said you need to have a status monitor that has an overall status, and then sender and receiver monitors, right? So let's have a look at that. So those are in features, conveniently. And here, if we search for NC sender monitor, you'll see that extends the status monitor. So we should have started with status monitor, has the right class ID again. Will have a role because it indirectly will derive from NC object, and it's got the overall status and the overall status message, right? All of those are very important. The overall status is an enum, and as inactive, healthy, partially healthy, unhealthy. All of that's discoverable by using the class manager. It's got still the generic get and set methods. We can get the values of properties. So that's our status monitor. And if we look at the sender monitor, then obviously that will have more properties. So it'll have the link status, it'll have messages associated with that, the transmission status, external synchronization status, and so on, right? All of those properties in that model. And they all work in the same way, right? So you've got get and set. This does a bit more because this also has an emulation feature to help with implementations. It does have the get method there. It has a set method there for all of those properties, right? And then we'll see very similar for receiver monitor. So receiver monitor derives from status monitor. It's got a different class identifier and different properties. It's got a connection status instead of transmission status, right? Some overlap, some don't, right? And again, you scroll down, you'll see beyond this emulation workload that you have the get and set methods. So, you know, the generic get all the properties that you need, and the set, right? And there are some set properties like the auto reset is the read write property. So those are sender and receiver monitors, and those are in there. One particular important thing with status, well, with sender and receiver monitors is that they need to implement a concept of a touch point. And that concept of a touch point means that each sender and receiver monitor has to refer to the UID of an ISO4 sender or receiver, right? Because that's how you know which of those resources you're monitoring, right? And that's why you'll see these have touch points. So if we scroll back here to the receiver monitor, then it's got a touch points property. So if we look at how that's instantiated in the server TS class, receiver monitor, and that's it. And you see, basically, we're passing in the identity of our receiver NMOS ISO4, ISO5 UID in there as a touch point, right? And it's a type of receiver. So this is how then a controller can figure out, oh yeah, this object in MSO502 and IS-12 is giving me information about a resource in ISO4 and ISO5, right? And I can show you that here as well. So if we look at, for example, receivers, my receiver monitor one, this is how this works, right? This is finding that touch point and matching it with the ISO4 and ISO5 receiver. So it's telling me that, oh yes, this object is associated with my NCO1 ISO4, ISO5 receiver, right? So it all kind of comes together identity-wise. So that's just another bit of information. So we've done the status monitors. I might be able to give you a quick kind of operational demo. There's also a concept of nested blocks. So this is just the idea that, you know, you don't just need to have the root block. It's better if you organize your information logically, right? So if I look back here, you know, we could have put all the objects in the root block, but what we chose to do is just put the managers in the root block, and then have other blocks like the receivers block. So the receivers block then has its own logical members, which is to do with monitoring the receivers, right? Then we have the senders block, which only monitors the senders. Then we have a gain, kind of stereo gain block, which handles that functionality. So it's just much better to organize your structures in various nested blocks that way. So that's all that is. And it basically just means that instead of just having all the objects in the root block, you create other blocks, right? And then finally, you have a concept of a non-standard class, right? And just to kind of show you briefly how that works, there is a specific section in here, which I'm will be going to go to right now. So what happens is if you create your own vendor specific class, you can derive from any of the, you have to derive from any of the standard classes. So you can derive from NC object, or you can derive from NC worker or NC receiver monitor, for example, and you can create your own variant. But that point form which you derive from, you have to include the identity of that. And then you have to put what we call an authority key, right? And there's documentation explaining how that's done. That could be a negative value if you have an CID or OUI, or if you don't have one, then you can just use 0 basically. But that's for everyone to know that from that point onwards, you are actually splitting off from the standard modeling framework, and you are doing your own specific classes, right? And they all need to not start with NC, because the standard classes start with NC. These ones will not start with NC. And I can give you a very quick example of that. We have one called an example control. So if I go to features, it's basically like a test class, example control, right? This derives from NC worker, but includes the authority key. So from this point onwards, I'm saying I'm splitting off, and this is kind of my vendor specific class branching model. So I've got an example control, which again has the same concepts, has properties. It still needs to do the get and set, right? Get and set, because that's how you interact with my object. And it still needs to create a class descriptor for my class manager. Obviously, this has methods as well, so I can invoke methods, and I'll show you that in a second. But if we scroll down a bit more, then this is the class descriptor. So even though it's my vendor specific class, I still need to have a class descriptor for it, so anyone can use it, right? In a generic way. So I can tell everyone, these are my properties, these are their types. If I have special types, I need to define them as well. For example, I've got an enum called example enum. That is not part of the framework, of standard framework, but it's still, I can create a descriptor for it, and I can tell you which values go into that enum. So if we go back to the class manager, you see I've got a descriptor for that enum, and I can tell you their labels and their values. So what that means is that a controller only needs to know if the device is IS-12 and MSO502 compliant, and then it can find everything there is about that device. So this is my vendor specific object. I can find all of its properties. I can see what they are. So this is my enum property. It's an example enum, right? I can still discover it, and I can query it. I can find that it's currently undefined, right? So all of that means I can use all of those features, even though it's a vendor specific class. So that is that checkpoint in there, non-standard classes. So I think that gives you a very good kind of overview of the probably 90% of the things there. They get you there. And finally, I should probably just give you a little demo. So what I've done here, I've mapped the receiver and status monitors, so their properties and things like that. And obviously the controller will subscribe to those objects and get notifications for them. But also in this mock device, as I said, the example control allows me to effectively trigger some emulation of faults with those senders and receivers. So I can control the emulation of a fault happening in the receiver or on the sender using IS-12, using MSO502. So, I can say my sender now is healthy or has lost signal, or my receiver is healthy or NIC1's down, or all the NICs are down. And when I triggered those, then you'll see effectively what would happen in a real device with the BCP-008 sender monitor and the receiver monitor. So let's go to some of that right now. So I've got my sender here, I've got my receiver. I will link them now. So this green here is basically my overall status. So that color of green is mapped to my overall status, which has now gone to healthy. So that was a notification coming back to the controller. So if I go back here, you see this is the overall status. That's my link status. That's my connection status. I've got synchronization status and my stream status, right? And here I've got some event counters. I can request packets lost or late, and then I can reset the counters and the messages. But effectively, this is the emulation bit, right? So this is how I can say, well, maybe now my device has lost NIC1, right? So you see now I'm getting notifications for all the domains and the overall status. So the overall status goes to partially healthy. Both my link and connection status go to partially healthy. I'm also getting messages, right? So NIC1's down. I'm getting packet loss on NIC1. If I go to all NICs are down, then obviously it's unhealthy. So everything goes red. The overall status is unhealthy. And then I can go back and I'll recover. There's behavior about delaying the recovery until you're sure. So that's why that's not immediate there. And I can do a grandmaster change. So for example, let's emulate the device kind of losing the grandmaster and going to a different one, right? So now I'm going briefly to partially healthy and going back, and I've ticked over an event there. But this all is driven through models modeled using the modeling framework MSO502 and interacted with using IS-12, right, through those commands and responses and notifications. And last but not least, using the behavior defined in BCP-008. Right? That's what allows us to have this level of interoperability. And what that means is I can use this panel with any device that implements IS-12, MSO502, and BCP-008, or 1 in this case, because that's the receiver. Basically, just map again these fields to the properties in there, and then I'm good to go. So that's kind of a brief summary of that. Hopefully that's been useful. It's been a bit of a long one, but I think it's been hopefully useful to you guys and showing some actual code and an actual implementation, going through the checklist and seeing where everything is. Okay. Yeah, thank you for hopefully watching this, and stay tuned for any other upcoming videos. Bye-bye.